Hello, welcome. My name is Diogo Oliveira, and in this video we're going to talk about cloud computing and cloud services. The idea here is to understand what cloud computing, which basically relies on the idea of virtualization. So the idea here is to understand what virtualization is, how it came to life, and how we got to the current stage, to the current situation that we see nowadays. How we can leverage that technology and what it has to offer to us. So as you already know, this is the fourth week, the fourth part of this combination of 4 different modules. So the topics that we'll be covering in this module: cloud computing foundation, cloud models. So we're going to talk about the infrastructure as a service, platform as a service, and also software as a service. Also, serverless computing, what is it about? What does it mean? And then cloud-based storage, so how data is stored as objects in file system. So basically how the data is stored in this new infrastructure. And then we'll finally focus on virtualization, containers, and Dockers. Okay, so first of all, we need to understand how the whole concept of virtualization and cloud computing came to life, right? So first of all, let's take a look at the idea of a server. So basically, a server is just a shared computer. As you can see here, we have a pie and we want to share that pie, right? But obviously, we not only want to share that pie, but we want to share that pie according to the taste or the will of that client, of that person, okay? So when you look at a server, which again is basically a shared computer, it's a computer that is there to share data, to share resources, and basically to provide services. You may ask a few questions. Does it really need a screen? Does it really need speakers? Does it really need a printer? Does it really need devices or an interface to communicate with the client or the administrator? Well, and in most situations, servers do not need that. So, for example, let's say that you want to play Minecraft, right? So I want to play in our Minecraft world, even if you can't make it, even if you can't be there, you cannot play at that specific moment. What it means is you cannot play at that specific moment, and you cannot be physically there in a specific location. So what it means is, first of all, to play a game, do I have to be in the location where that game is being provided? Well, if it's, and that's what we see nowadays, right? If it's there is an infrastructure that is remotely accessible, then you do not. Okay, but that's in the past. It's been done for quite a few years, well, many years actually, quite a few decades now, right? So for example, Minecraft is a more recent example, but if we look at the example of Ultima Online, WoW, that's an example of a MMORPG game in which you have that infrastructure that is remote, and you can simply connect to that infrastructure, to those servers, and play. But not only that, in WoW or Minecraft, you can leave your game on. You can, although you're, let's say, as you can see here in this image, although you are sleeping, your character or your avatar, your virtual character, your virtual representation is plugged into that game, that environment. So the whole idea is to make that infrastructure available from anywhere, right? So the cloud symbol was used by ARPANET in 1977. So you can see that this is not something new, right? To represent a bunch of networked computers, okay? As you can see here in this image. So that's how the concept of cloud computing came to life, okay? It started as a symbol to represent, basically, at the time, the idea was to represent the public internet connection or the internet. So again, going back to servers, right? If we look at the servers that we had in the 90s, in the 80s, in the 90s, and even in the early 2000s, servers, they would provide shared resources, okay? They would be always on, and they would always be connected to the local network or the internet. Obviously, it depended on the type of situation, right? On the scenario. There are servers that they are only internal. They are providing services, sharing files, sharing printers for the local users, the users that are within the premises, okay? But most commonly, you're going to find servers that they are providing service to the public network, to the internet. Okay, so as you can see, shared resources, they would always be on and also connected to the public network. Okay, but then you look at a few other situations. And here we see Jeff Bezos in 1990, right after Amazon was created. And basically a concern that he had at the time was, okay, I need 1,000 servers. Well, not the concern, but in his mind, maybe this was a necessity, right? So maybe he thought that he would need 1,000 servers to store his the products that he needed. So his online bookstore would need 1,000 servers to provide to serve to serve his needs, right? Because maybe somebody else could use some of these books in January. And what it means here is, okay, there are maybe in a specific time of the year, you are providing services, but you don't have many clients. But there may be an occasion or a few occasions where your systems is going to overload if you did not provision accordingly. Okay, so maybe we can run different web services on the same server, right? Which means that that became possible even using servers, the traditional servers, right? In which you could implement multiple DNS names associated with the same IP address. And this is, for example, if you've ever configured the Apache web server, you are probably familiar with the concept of virtual hosts. And this is what it's about. So it's the capability of associating, well, you can just register a domain and associate that domain with different domains. You can register different domains associated with the same IP address. But the problem here is the first thing that we learn about DNS, the DNS protocol, is that basically the idea is to allow you to associate a name with an IP address. And what we're looking at here is the possibility of associating different DNS names with one single IP address. And you can do that. Different content associated with different domain names, but hosted in the same machine, associated with the same IP address. Again, if you implement virtual hosts, for example, okay? And you can also provide private FTP login to upload content to a website. A very common example here, and maybe you've used this in the past, is the university provides an environment that will allow me to create my personal web page using their web server, right? So let's say that you have a domain, domain.edu/tilt user1. Then you may also have another student may have domain.edu/tilt user2. So two different websites, two different environments, and they're all in the same server, right? So yes, you can also do that using the traditional servers, those ones that we had in the 90s. Okay, very good. But then we start to see a few problems here. First of all, that is almost the opposite of what Jeff Bezos' bookstore needs, right? Because the challenge is to scale beyond a single server. So what he saw was, okay, what I need cannot be provided by one single server for overloading purposes or reasons, right? So therefore, what we see here as a solution is to combine servers. So we need shared computers, right? But also we have to span the load and the data across those systems. Okay, but then a few questions come to life. First of all, is it safe to share data among different computers, right? For example, what if I need a LAMP server, okay, and someone else needs a Windows 2000 environment with SOAP? So what you can see here is, okay, if we go back and analyze that situation where I have one single server providing hosting, data hosting a web service for two different clients, as you see here in this situation. Okay, if there is only one, I have two different web pages that should be serviced, hosted by the single server. But those two different pages, they can be hosted in the same environment, the same architecture. That's perfectly fine. As I mentioned, you simply need the Apache web server running in, for example, a Linux system and a MySQL database being accessible if those web pages use the PHP web language. Okay, that's fine. However, what if the other client that I have relies not on LAMP, but in a different infrastructure, in a different solution that depends on a different architecture? Therefore, what I need is one Linux system, one Linux architecture, and one Windows operating system. Can I run those two solutions, right, such as SOAP, that is going to run in a Windows environment, with LAMP with a Linux system? Well, originally we could not do that. So then came the idea of virtualization, right? So in 1999, VMware Workstation virtual machines came to life. Although officially VMware came to life in 1999, the products actually came to life in the early 2000s. But as you can see here, the idea is, as we mentioned before, I have one single system. As you can see in the back, it's a Windows system, probably judging by the interface, probably this is a Windows server, and this Windows 2000 server is running two other virtual machines. It's virtualizing two other machines. So here you have the character of a hypervisor or a host. Let's refer to it as a host for now, right? Which is the operating system that is actually running on the physical machine. And then inside, on top of that operating system, of that host operating system, you have not only two different systems, but not only two different operating systems, but two different machines, two different virtual machines. Now, if these two different machines are virtual, but still they are virtual machines which represent two different computers, where do their resources, such as CPU, RAM, storage, where does it come from? Well, they come from the physical machine. So basically what you have in a virtualized environment is the creation of two, let's say, fake virtual machines representing machines, but obviously they are virtual. They do not have the physical resources. So what the host is going to do is to provide them with the resources that they need, the physical resources that they need. So the CPU, the computation capability will be provided to both virtual machines. Some storage will be provided to them as well. Same thing for RAM. Now, obviously, if your machine has, let's say, 8 gig of RAM, and you cannot assign 8 gig for each machine if you're going to run those two. Well, you cannot even provide, let's say, 6 gig to each of those machines if you're going to run them at the same time, right? So it's a shared environment, which means shared resources. Okay, but if you look at the situation here, what VMware created in the early 2000s, what you can see is that you have a local machine, right? A local physical machine that is virtualizing those two other virtual machines, creating those two virtual machines. Well, which is pretty nice, but only if you are the only person that is going to work on that machine, the physical machine, and on those two virtual machines. So in 2006, Amazon created Amazon Web Services, and they came up with a solution called Amazon Elastic Compute Cloud, or Amazon EC2. So two keywords here that you already understand. So compute cloud, basically the idea of a cloud, right? Allowing you to create a virtual environment that is publicly accessible through the internet. What about elastic? Where does this keyword come from? Elastic represents elasticity, which means that you can you can dynamically provision and reprovision those virtual environments. So the idea is to implement this, but not locally. Implement it publicly available through the internet in such a way that you can, let's say, reshape those those virtual environments. So basically, you can use a web interface that you just go there and say, hey, I need a virtual machine, okay? And they will provide you with templates, okay? So Amazon EC2 will allow you to select the type of virtual machine that you need according to physical resources such as RAM, CPU, storage, bandwidth, network bandwidth. Also, the operating system. So you can select not only the operating system such as Windows, Linux, but also the distributions or the versions of those operating systems. And once you've done it, you can also reshape those those virtual machines. You can add more RAM to them. You can add more storage. So therefore, elastic. So basically, you are renting virtual machines via a simple web interface that you can scale up and down as you need. So then if we compare this with the servers that we had in the 90s, okay, so again, those servers, they provided shared environment. They would always be on with connectivity the entire time to the public network. They would also provide you the possibility of implementing multiple DNS associated with single IPs and an environment that is accessible by many users, but they did not provide elasticity. So as you can see, server rooms can scale, but not quickly and not cheaply. And on top of that, there is only so much that you can scale in server rooms, right? Now, specifically talking about Amazon AWS services, they're still leading among others, but it's very important for you to understand that there are other providers, such as Microsoft Azure, that is probably the second one, coming right after Amazon AWS, also very famous. You also have Google, the Google Compute Engine, the Alibaba Cloud, IBM, Dell, DigitalOcean. DigitalOcean is also another big one, at least in the United States. So you have so many different cloud providing services. And still to continue to expand all that, in 2006, as you can see here, Jeff Bezos, he was able to get a hold of a contract with DARPA. So in 2021, DARPA approved a contract, a funded grant to finance. It's not only Amazon, but a combination of many companies, but led by Amazon. So Amazon has a project called Blue Origin. And the idea of Blue Origin is to allow people to go to space and, if possible, even visit other planets. So the idea is what Jeff Bezos has in mind is that the Earth won't be able to host us for a very long period of time. So we're making the resources here scarce. Therefore, he and a bunch of other people are trying to find a way of making it possible for people to live in the space or other planets. Something similar to what Elon Musk is trying to do. Okay, so he was able to secure that contract. And obviously, this only expands the idea of virtualization, because then you still have that connectivity with all those people that are supposed to go there. But not only that, how is this project will be made possible? How is it going to be? How is it going to occur? How is it going to become tangible, right? So the Amazon EC2 and the Amazon AWS services as a whole are very important to allow that communication, to allow that elasticity, to allow that complex environment, specifically in regards to the data processing and communication with the space devices or devices that are in space. Okay, so basically, as you can see here, cloud computing is a combination of remote services. You need backup and disaster recovery techniques, but you also have the virtual desktops and the virtual applications, as well as web hosting and application hosting. Okay, so what it meant to begin with is virtual servers connect with virtual networks. And virtual networks is basically the implementation of VLANs. And a VLAN is nothing more than one extra number in the Ethernet header to allow you to separate physical networks, creating virtual networks. So the reason why VLANs are so important in cloud computing is because imagine that you have Amazon AWS and Amazon EC2 infrastructure. Well, although the elasticity can be provisioned hosting all those virtual machines in one single virtual environment, in one single server, well, ideally, that's not what you want to do, right? Because if you are Jeff Bezos, because you want many clients. If you want many clients, not one single server won't be able to service all those clients. Therefore, you have several servers in a data center. But how can you create segments within that data center? So VLAN, not only that, but VLAN is one of the technologies that can help you with that, to create segments within a local area network. Therefore, VLAN, virtual local area networks. Also, you have to be able to manage those virtual machines remotely, and you must also be able to program those virtual machines using APIs. Right? Which means that you need infrastructure as a service and infrastructure as code. Okay, so what is that about? Infrastructure as a service is simply the idea of allowing clients to create virtual machines using a physical infrastructure. So once again, Amazon AWS provides a very complex, strong infrastructure, powerful infrastructure, and resilient. And then the AWS clients, they can use an interface to basically say, hey, this is the type of virtual machine that I need. And then that virtual machine is created for that client. Now, observe that the client is using a virtual machine that represents a physical machine, but that client does not have access to the actual physical infrastructure. So the infrastructure is provided to the client as a service. But not only that, those clients, they must be able to, once again, implement elasticity, make use of elasticity. Therefore, you have that infrastructure as code. So softwares must be deployed, must be put in place in order to allow the clients to easily manage their virtual machines. And also, Amazon AWS wants to they need an interface, not just one single interface, but they need solutions that will allow them to manage all those virtual machines. Also, you want to integrate that with cloud storage, right? Databases, message queues, DNS services, denial of service, distributed denial of service protection, authentication, load balancing, all those different services are very, very important, specifically for Amazon AWS in this case, because once again, Amazon has a bunch of clients. They need to make sure that each client virtual machine or virtual machines, any services that are being provided to a specific client, is not going to touch another client's services or data. So to summarize what we looked at as far as history goes, before 2000 and specifically in 2000, so before 2000 we had the traditional infrastructure. In 2000, specifically in 2000, then moving forward to 2001, that's when VMware came to life with their virtualization technology. Then in 2006, the public cloud AWS EC2 service, Amazon EC2, came to life as well. Then 2010, we started to see OpenStack, which at first was Red Hat OpenStack. And this is the idea of OpenStack is to allow you, to provide you with that what is called management and orchestration capabilities. A very complex and powerful software, or combination of softwares, or combination of modules, if you will, that will allow you to manage all that complex cloud-based infrastructure. So, for example, if you want to deploy, instantiate one virtual machine in one location, and then another virtual machine in another location, and then you want to implement load balancing between all those different virtual machines, and also you want to implement NFV, network function virtualization, software-defined networking. So OpenStack is a complex, powerful solution to combine all those technologies. Then, to make it even easier, we saw Docker coming to life in 2015, and it was actually it was enhanced, its power was enhanced by Google Kubernetes. So the idea here, the idea of a Docker, of the Docker software in general, okay, not a specific Docker instance or container, but the Docker solution itself, is that you can now create, similar to the idea of creating those virtual machines, template for virtual machines, you can create template for any type of software, combination of softwares, or even an entire operating system. So basically, what you do is to create a pod. That's what they call it, a pod, which is you would create a software that you want to create, or an operating system, or combine several softwares, and you would kind of put all that together in one package. And then you can use Docker to instantiate that package. So it's very easy to, for example, if you want to deploy a MySQL server, okay, there is a MySQL server container, and then you instantiate that container, creating a pod. So you can do that with so many different softwares, right? Actually, with any software, because you can also create your own pods, your own containers as well. And Kubernetes, what it does is basically it allows you to manage all those, one example, Docker pods, Docker instances. So as you can see, if you start to create many Docker, or if you need to instantiate many Docker instances, managing all those different instances can be very complex. So Kubernetes can help you manage that. And also you can scale in such a way that you tell Kubernetes, hey, this is the type of Docker instances infrastructure that I need. Basically saying, I need these number of Docker instances, and each of these instances should be hosted in these servers, different servers. So you define that with Kubernetes. And then Kubernetes will make sure that all those instances will be created, instantiated, and distributed in that proper manner. And then in 2018, we started to see the combination of public and private clouds, which resulted in the hybrid cloud. Now, I mentioned earlier that we also have infrastructure as a service, as you can see here, but that's not the only cloud service that you have available. Actually, there is a bunch, but the most important ones, and you're going to see these ones more often. As I mentioned, infrastructure as a service, IaaS. You're also going to see and probably use platform as a service. So platform as a service is this is something that is very common by using Docker, right? So if you look at the LAMP solution, the combination of Linux with Apache web server, accessing a MySQL database management system using the PHP language, right? There is a number of softwares that must be combined, an operating system, and running that operating system, all those three different softwares combined and configured. So you can do that and then create a Docker instance containing that. Now, you can provide that to your clients, and Amazon does that as well. So provide that to the clients so that the client, if the client doesn't need or doesn't have the skills to hire IaaS, meaning hire a service to get a virtual machine and then build up all those softwares in that virtual machine. That's way too complex, time consuming, maybe unproductive. So you can provide to your clients that platform with all the softwares that client need, the platform as a whole. It's not a single software. So you have the PaaS, platform as a service. Similarly, but less complex, you have the software as a service, or SaaS or SaaS. So the same idea, but it's not a platform. It's not a combination of solutions. It's a single software. And this is something that you see and use basically every day, I'm pretty sure. One example is your Microsoft Outlook email account. You're basically using a software that is hosted in the public network, but it's a software that is being provided to you as a service. Obviously, you may also have some solutions that are not executed in the cloud. You have to install, download, and install the software. But the way that it's going to execute is going to be by providing you a software that is available through the public network. Now, you also see here the idea of business process outsourcing. The only reason why we have this here is to allow you to identify what outsourcing is. And that's basically what these services, these cloud services are about. Allowing you to outsource services. So you may outsource your infrastructure, meaning you may hire that infrastructure that you don't have from a service provider. You may hire a platform that you don't have or you don't want to deploy, right? So you hire the platform as a service. Same thing for a software. This is something that is very common, and it's been there for more than decades, which is business process outsourcing. So it's the same idea, the idea of outsourcing, right? Very common, which is your company does not want to hire people to work to do telemarketing, for example. So you hire a company to do that for you. So again, it's the idea of outsourcing. Okay, so in the cloud computing model, this is what you see. You have a data center with computing hardware, network equipment, operating systems, a middleware, an interface, cloud applications, and then you have the end user. So the end user is going to go through all these layers, right, to get the service or the data that they need. Now, virtualization can happen in two different ways, basically in two different ways. You may have the type 1 virtualization or type 2 virtualization. Type 1, and there is another one that I will also mention, which is Docker, right? Docker is a different situation, and also what is also very common to see nowadays, and that's what Amazon EC2 uses, which is containers, but system containers. Okay, so but let's focus on the most common virtualization types. We have the native or type 1, and we have hosted or type 2. First of all, before explaining them, let's look at two examples, different examples. I would assume that you've used VirtualBox or VMware Workstation. Okay? And I'll make that assumption to give you an example of the type 2 hosted virtualization. In a type 2 virtualization, you have your hardware. On top of that hardware, you install your operating system, the traditional commercial operating system, such as a Microsoft Windows 10 or Linux CentOS 8, any of those operating systems. On top of that operating system, you're going to install a hypervisor, such as VirtualBox or VMware Workstation. That's how you create that hypervisor. The hypervisor is the software that will control the interaction between the virtual machines and the resources. Just one example, but it also controls a bunch of other stuff such as security. But let's focus on resources. So the hypervisor will be responsible for assigning the resources that you as a user want to assign to those virtual machines. So remember, the hardware does not exist for those virtual machines. It comes from the physical hardware, right? RAM, CPU, storage. So the hypervisor will be responsible for communicating with the hardware or the operating system, in this case with the host operating system, to provide the resources to those virtual machines. As you can see here, in a type 1 virtualization, using KVM, using Xen, using VMware vSphere, those are type 1 virtualization solutions, or native virtualization. So you have the hypervisor running directly on top of the hardware. So you have a bare metal server. There is no operating system in between. Basically, you have a very simple, lightweight operating system, or firmware, if you will, that is running directly on the hardware and managing the operating system. As you can see, as you eliminate this layer here, the performance here is a lot better. It's much safer, it's more performable. Overall, it's a better solution. But then came the idea of Docker and containers, operating system containers, which is, it implements a solution similar to the hosted type. So you have the hardware, you have the operating system, but here you don't have the hypervisor itself, because the hypervisor is a very intelligent, complex system. What you're going to have here is a container management software, such as Docker. A simple software that is there to deploy those pods. So remember, the pods are much simpler piece of software or piece of code. It's not an entire operating system. But you may say, oh wait, you can run operating systems as pods. Yes, you can. But most of the time, that operating system is not going to be a full-blown operating system, which means it's going to be a specific operating system. For example, you need a Linux CentOS 8 and you do not specify the services. So there is a pod that is only instantiating a very minimal operating system. maybe you're not even gonna get the bash shell. It will just come with a very basic shell. Okay, so the idea here is to minimize as much as possible the weight, the intelligence over here. So in 1999, VMware invented virtual machines, but once again, you should consider the 2000 specifically. But it was made popular on workstations or PCs, right? On x86 architectures. Why is that important to mention? So let's take a look at a brief history of virtualization. And we are starting about 2300 years ago. So it all started with the original hacker, that's what they call him, Euclid. So Euclid, he came up with a bunch of mathematical models, and one of those models or ideas or theories were regarding the prime numbers. So he created the theory that you have infinite number, an infinite number of prime numbers. Okay, so that's one theory, right? But then David Hilbert came with the idea that we want to prove that we can prove anything. Okay, so what is that about? The idea is you can come up with theories, but you have to prove that theory. Ideally, that's what you want. We see that in academia every day, right? In academia, you are trying to publish papers, publish your research. And your research should be funded you should be able to prove what you're stating. Okay. But not only that, the idea of a peer review, so let's say that you're submitting your paper to a peer-reviewed journal. So what those people are going to do is, ideally, what should happen is they should be able to mock your tests to verify that it actually works. So they should be able to make sure that the statements that are making are true and they can be proved. But some mathematical statements cannot be proven nor disproven, right? So Kurt Gödels came with the idea that although you cannot prove some mathematical statements, you cannot disprove them as well. So are we wasting our time looking for proof, ways of proving our ideas? So again, with all that idea that, okay, if you want to make a statement, you should be able to prove that. And we should be able to prove your proof. Okay? So the idea of the peer-reviewed journals that we have nowadays, it's a similar idea. Okay, so a bunch of mathematicians, they started to question themselves. Can we make an algorithm to determine if a statement is provable? Basically saying, hey, can we create a software, for example, that whatever theory you provide as input to that software, the software should be able to say it's provable, it's not provable, it's correct, or it's not. Well, so Alan Turing, he basically said, nope, you can't. Okay, and let's remember that Alan Turing invented the computer, right? So he created the Turing machine, which is a mathematical version of a computer program. So as you can see here, in this sort of Markov chain infrastructure model, mathematical model, you can see that there is a backpropagation of all the output, the input of one phase becomes will generate an output, but it will be retro-fed to that same cell, okay? Now, what actually matters here is that you understand what a machine is, according to Turing. A machine is nothing more than a combination of functions, mathematical functions. And these mathematical functions, they come from what we as human beings taught the computer. So basically, a computer will only be able to generate an output based on mathematical models, which are models. They were modeled before. Therefore, it's not possible to create a software or a machine that will look at something that is brand new, a model that is brand new, and determine whether it is provable or not, whether it is true or not. So a universal Turing machine can run any Turing machine, therefore it can run another Turing machine. It's like a computer inside a computer. So what does that tell you? If the Turing machine shows you that there is a bunch of mathematical models, that they can be executed one inside of the other, it cannot tell if a new model is true, but it can run one inside the other, as we can see here. One model can be fed to another model, which means that one can be executed inside the other one. Well, that's exactly the idea of virtualization. The possibility of creating virtual computers, instantiating virtual computers inside physical computers. So, one thing that you need to understand, it's very important to understand, is that virtualization is better than emulation. And why is that so? Because emulation is, okay, first of all, there is a difference between simulation and emulation. And simulation is basically a software that is forging, using functions to forge an instance of something. Emulation is the actual creating using codes, but it's actually creating what is to be instantiated. So, for example, if you've ever used GNS3 to emulate a network topology, those switches, routers, workstations, all those devices that you put in your topology, your GNS3 topology, those are emulated components, emulated devices, which means that if you have a switch that requires, let's say, 256 meg of RAM to execute, it will consume 256K of RAM of your machine, the physical machine. But it's a software that is emulating small functions. Virtualization is it's a way of creating an entire system on top of the physical system, an entire hardware. So hardware virtualization in IBM computers, they came to life in the 60s. And Popek and Goldberg, they actually showed a simple mathematical model to prove the requirements to implement virtualization. So again, that's back in the 60s. Only 30 years later, actually a little bit over 30 years later, Intel implemented the support to virtualization in their processors. Now, this virtualization technology, right, which you can see in a by the Intel VTX technology or AMD V technologies, is what allows you to implement, to instantiate Type 2 virtualization. Use VirtualBox or VMware Workstation, for example. Again, in 2006, we saw Amazon EC2 come to life with the Elastic Compute Cloud, which is literally the same year that we saw Xen Hypervisor. Also, now, again, Type 1 virtualization, both of them. So, an overview of virtual machines. Alan Turing invented the machine nesting, the capability of creating one machine inside the other, that we can call that emulation. IBM added hardware support virtualization in their 60s frameworks. Popek and Goldberg, they formalized that model. VMware popularized virtual machines, mostly to help developers support different operating systems. Amazon built the infrastructure ecosystem around virtual machines we now know as cloud computing. And Intel added support to Type 2 virtualization to their processors. So this is how cloud computing evolved, came to life and evolved during these about 2 decades. Although, once again, virtualization is a concept that's been around for roughly 60 years. But it only evolved, became a technology, a feasible technology in the past 2 decades, evolving to what we have nowadays, implementing virtual machines with all those instances that are very elastic. You can migrate very easily. You have OpenStack, that's just one example. A management orchestration solution such as OpenStack to make your life even easier, especially if you are a cloud service provider. So that's how we evolved in this area. I hope you enjoyed this video and thank you very much.